In the previous tutorial, we saw random floats, which is the default data type. But what if I did want an integer instead? Now there's two ways of doing this, but this way introduces rand, which is common to a couple other languages like C programming and others. So the examples I'll talk about are simulating games or simulating random events such as rockets taking off. Or how about encrypting? All of these could use random integers. So remember that right now we're a little bit stuck. The rand function alone, if I just type rand, generates a float between 0 and 1. We've tried it. We've even tried putting stuff inside the parentheses, arguments. It's completely not related to the numbers. It's always between 0 and 1. So to round, guess what? We're going to use the rounding functions. We have three rounding functions. We have round, floor, and ceil. Just a quick recap. The round with respect to 0.5. Floor, look at your feet. It goes downward. It rounds towards negative infinity. And ceil, well, look up. It rounds towards positive infinity. So here are a couple examples if you want to refresh your memory. But what if I want to combine them? Right now, if I do k equals rand times 4 plus 3, it's going to be between 3 and 7. Okay, great, but I wanted a whole number. What happens if I did round in front of that? And specifically not just k, because round of k would be 6 right now, and that's a constant. But round of rand times 4 plus 3. Notice how we can combine all these keywords. Well, I'll either end up with a 3, 4, 5, 6, or 7. Here's a little idea of how to figure these things out. I was in between 3 and 7, so the closest to 3 that I could get was maybe 3.00001. So I'm sat close enough. What is round of that? Well, that's a 3. Do the same thing on the opposite side. A little bit before 7, so 6.9999999. That's as close as I'm going to get. If I round that value, I end up with a 7. So any integer in between 3 and 7 included will be attainable. If I had done floor instead, well, a little bit after 3, right before 3, well, that becomes a 3. And same thing, a little bit right before 7 becomes a 6. So notice how the 7 is no longer included in that one. Ceil does the opposite. It basically does not include your lower limit because you're going up with the ceil. You're going upwards, so the lower limit, poof, goes out the door. But you can do the same mentality of thought process to come up with that too. Let's go directly into our examples. How about games? All of us love games. We have 4 players and we want to decide who starts first. So we're going to indicate a number between 1 and 4. And let's throw 2 dice, maybe between, I don't know, we'll pick a dice that can go from 1 to 20. Let's try that. Okay, so I've even pushed it a little bit. Let's do dice and card game. CLC clear, set up the number of players. Because not everything has to be hard-coded like our examples on the slides. Of course, use variables. Who wants to play first? We'll roll the dice. So we want to generate a number between 1 and a number of players. So 4, 10, 6, who knows. And then let's generate 2 cards, but only between 1 and 10. Let's not go above to the figured cards. So how do I generate between 1 and 4, or 1 and number of players? My idea right now is to start with rand. So I can start with rand times number of players. So what would that be equal to right now? Just so testing purposes, I'll hard code the other 2. Number 3.25, 3.62, 0.5. So it looks like I'm between 0 and 4, which is exactly it. If I am between 0 and 1 with this and I multiply by 4, I'm between 0 and 4. So which rounding function should I use so that I don't hit the 0 anymore, or 0.5 becomes obviously player number 1? The ceil function. So in this case, I'll do that. I'll hide these 2 so it tests even faster. 4, 3, 1, 2, 1, 4. Perfect. So let's see if I can change this to 45 players. Still works. So here, I am not actually using real hard-coded values. I'm definitely using number of players of variables. Could we have done it with floor or round? Absolutely. Let's do it. Maybe player number 2. If I do rand times and I follow the formula, n players minus 1 plus 1. So there I'm generating between 1 and 4. So almost close to 1 and almost close to 4. So which function should I use now to hit the 1? The floor. But which function should I use to hit the 4? The seal. So in that case, I'm actually needing the round function. Let's see if that works. 3, 4, 3, 2, 1, 3, 4. All right. And I could definitely do the first player number 3 maybe with the floor function. The floor function you would generate between 1 and 5, so that anything close to 5 becomes back to a 4. So there's always 3 ways of doing these problems, no matter what. Whatever one makes sense in your head, stick with it. Let's practice a little bit more again. How about generating 2 cards? I need a card between 1 and 10. Well, I can easily do rand times 10. So that'll be between 0 and 10, both not included, so inside the 0 and 10. And I want 1 and 10. So, seal. Same idea. You'll get 0, but you don't want the card 0, so you'll seal it to a 1. You'll almost hit 10, but you do want the 10, so again, by sealing it, you actually hit it. And I could do the same with card number 2, showing you round and floor. But let's do another example. Rockets. How can we test the codes, and those are million lines of code, without actually hooking up to the rocket? You can't think that the only way of testing is to actually have real hardware. That's completely unrealistic with rockets. They cost way too much. How can we tell the doors are locked? How can we tell the rocket is fueled? How can we tell the weather's good? Those are all sensors, but we don't have them. In this case, you want to generate a 1 or a 0, a true or false idea. So here's a code about rocket testing, and I have the same sensors. I have a doors locked, a rocket fueled, or weather being good, and below this I have something we haven't learned yet, if statements, to decide whether I should go or not. So we're not going to focus on that. But, for example, here I ran my code with a 1, and a 0. The doors were locked was true, the rocket was fueled was true, and the weather was good was bad. So the weather's not good, basically. So I'm like, who cares about the sensors? There's lightning, don't even try it. How about putting a 0 here instead, but making a weather look good? Oh, okay. So the weather is good, we could have gone, but someone forgot to put fuel, so we can't. Alright, and we can test this, but notice how tedious it is, so maybe doing a random function could be a little bit more fun. So how do I generate a number that's actually 0 or 1? And of course, there's 3 different ways, so that's why I have 3 different sensors. The basic would be to start with rand, but rand generates in between 0 and 1. So what happens if I want to make the 2 boundaries actually hit? Well, anything close to 0 needs to become a 0. That's floor. Anything close to 1 needs to become a 1. That's seal. So what's the in between? It's definitely round. So the round of rand will give me a 0 or a 1. Let's try it. So notice here I'm hitting F5, doors locked. So this is the first one. 0. Oh, here's 1, here's a 0, 1, 0. So it's very easy to test, and you see that it changes a lot. What if you didn't like the rand function? Let's use the seal now. If I want to use the seal, now seal rand is completely dumb, because if you seal a number between 0 and 1, you'll end up with a 1, so might as well just hit 1. But, alright, so rand is between 0 and 1. I want to seal something to hit 0. So I need to start with -1. And then I want something to hit 1. So I need to be between -1 and 1. So that's an interval of 2, and I start by 1. So let's see if that works, or did we do a mistake? The way we do check if there's a mistake is by testing. And honestly, even that, I could potentially never hit a mistake that I did. So make sure you check your math at any time. It appears I'm hitting 1 and 0, so I'm going to be okay with that. Last but not least, floor. So on this one, again, you start with the rand, you multiply, and you do something. But I want to hit 0 and I want to hit 1. So I need to be above 1 to make it come down to 1. So I need to be between 0 and 2 this time. So there you go, 0 and 2. So between 0 and 2, and I'll floor it. A little bit above 0 will become 0. A little bit above 1 and less than 2 will become a 1. Test, 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 test. Perfect. All right, so again, a lot of ways to generate numbers, but this is one particular way that's actually very used to generate a true or false idea. Again, the code below is not what you're focusing on. We'll show you that very soon. Last example, how about encrypting? Encrypting data. So you have data, it looks good, and then you don't want someone to take over it, so you encrypt it, you email it to somebody, and you give them the key so they can uncrypt it. Well, how'd you do that? Well, so we have an original 16-digit credit card number, and somehow I want to encrypt it so I can email it or complete a transaction. Well, that would be maybe your key to actually encrypt. So let's generate a number between a lot of 1s and a lot of 9s. So a big number, and let's just add it. Okay, so how would you go about that? You can't add decimals, of course, but you have to start with rand at this point and do the math. So if you want 8888, 8888, 8888, that's the range. Remember the big number minus the small number. And then add where you want to start with. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. But again, that's a decimal value. So seal round or rand. Depends if you want to hit or not your boundaries. If you want to hit both, it's the round. If you want to hit the top, then it's the seal. And if you hit the bottom, then it's the floor. I'll do the round again. But remember, this is just an example, so you can choose whatever you want. All right, run. What's this notation? This is exponential notation. So 3.1026 times 10 to the power of 11, and that's good. It's a decimal, so we're all happy. Now maybe I just want to do my original credit card number plus my key. So now I have 2 encrypted data. To show the actual key, you might want to do an fprintf. There. So every time you run, you get a new updated encrypted credit card number. The only time the person at the other end of the line can decrypt is if you pass the key with it. So usually in a different email maybe, or some other type of encryption data. We could also change the first number. Right now I didn't change the first number. Let's change that. First num, I'll do seal of rand times 9. Why? Because I want to be between 0 and 9 and then seal it. So the 0 will become a 1 and the almost close to 9 will become a 9. Why not? Now, how do I add the first number? I just want to change. So the 4, if I generate a 6, will become a 10. That's okay. So how do I change that? Well, I'll do first num times 10 to the power of 15. So in that case, not only will all the numbers behind change, but the first number will also change. So that's another way of using random numbers. Why not? You want to encrypt. That's actually very highly used. As long as the other person has the key, then it can do the reverse operation. Let's wrap up. So today we did move away from float. We wanted random integers. But the idea here is to stick to the rand function, which is used in a lot of other languages. We generate a random value, and then there's 3 ways of shifting it to being whole numbers. We also use that for 0s and 1s to simulate event. Did this happen? Is this true? Is this false? It's a very practical way of simulating events. I did 3 examples and I made sure to kind of see all 3 options each time.